Welcome to Spring LIB.
The average velocity of a molecule at a particular temperature is going to increase as molar mass decreases. So we can put these in order of increasing average speed or velocity by simply putting them in order of decreasing molar mass: SF6, then HBr, Cl2, then H2S, and then CO. The one that has the smallest molar mass will have the greatest average velocity. This is according to the kinetic energy equation. Kinetic energy equals 1/2 mv squared. So if they all have the same kinetic energy at a particular temperature, which they will, as the mass decreases, the velocity increases. Next, you're asked to calculate the root mean squared velocity for just CO and Cl2. So this is just an equation that is provided in your textbook. And the equation is the root mean squared velocity is 3 multiplied by r, which is the universal gas constant, but you're going to use the value 8.314 instead of 0.08206. This is because we're working with units of energy, multiplied by the temperature in Kelvin, which is provided at 300, divided by the molar mass. Now this is where most students make the mistake. When you divide by molar mass, you need to divide by the molar mass in units of kilograms per mole, not grams per mole, or this equation won't work. So for CO, it's 38 grams per mole, so it's going to be 28 grams per mole, so it's going to be 0.028 kilograms per mole. Then don't forget to take the square root, and you should get 517 meters per second. Then we'll do the same thing with the only other one that they requested, Cl2. Cl2 has a molar mass of 70.9 grams per mole, so that's going to be 0.0709 kilograms per mole. Again, we'll be at the same temperature, and then these two values, 3 and the 8.314, are constants. Taking the square root, you should predict that this greater molar mass is going to result in a smaller root mean squared velocity, as we determined up here. And sure enough, we do get a smaller value of 325 meters per second. Next, we'll calculate the most probable. So the root mean squared velocity and the most probable value are slightly different. And you'll notice that because the equations are slightly different. What is replaced is we put a 2 here instead of a 3. So the most probable value is slightly smaller than the root mean squared value. So it'll be 2 times the same r value, 8.314, multiplied by the same temperature. They're requesting it also at 300 Kelvin, divided by the molar mass, still in units of kilograms per mole, 0.028 kilograms per mole for carbon monoxide. And we get a value slightly less than what we had up here, 422 instead of 517. Then we'll do the same calculation with Cl2 that has a larger molar mass, so we should end up with a smaller, most probable velocity. Remembering to convert this to kilograms per mole. And don't forget to take the square root. And we get 265 meters per second instead of what we had up here, 325 meters per second.